Bismillahirrahmanirrahim. Students, today starting with the new topic that is logical equivalence. Two statements are called logically equivalent if and only if they have identical truth values, right? They are going to result in a same logical inference whether it is true or it is false. You people must be familiar with the logic gates, and the basic logic gates are and, or, and, not, right? AND gate, which is denoted by this hat symbol, inverted hat symbol for OR gate, and this or tilde sign for the NOT gate. Now there are certain logical rules that we are going to follow while solving certain predicates or while solving certain logical equations with the target of either reducing them or showing that one logical statement is equivalent to the other statement. Now, starting with these rules, starting with the most common rule, which is known as commutative law. Commutative law claims that for any two variables or predicates, say P and Q, this is equivalent to Q and P. Same is the case for OR, that is P or Q is equivalent to Q or P. Second law, which is known as distributive law. This law states that P or Q or R, right? This is equivalent to P or Q or R. The requirement is that all the logical operators here are same. Similarly, in case of AND gate, P and Q and R, this is equivalent to P and Q and R, right? Third one is the distributive law. Distributive law of addition, AND over or OR over AND. Sorry, I have written something wrong here. This is not a distributive law, rather this is associative law. Associative law. Okay, according to the distributive law, P and Q or R. How I am going to read it? And is distributed over OR, right? On the right hand side, we are going to have P and Q. In between operator is OR, so P and R, right? On the other hand, where we are going to have OR distributed over AND, this is equivalent to P or Q. In between operator will be and this time P or R, right? So this is the distributive law of OR over and AND over OR. Now another law which is known as inverse law, right? In case of inverse law, let me first make you familiar with two terminologies that are very important. First one is known as tautology. Tautology means something that is always true. It is going to have a status of true which is logically equivalent to 1. And we denote a tautology with T symbol, right? Second terminology that you people should be familiar with, that is known as contradiction, or you may also say it fallacies. Anything that is always false with a logical value of 0, and we denote it by either C symbol, or sometimes you may see F written against it. So tautology is something that is always true with logical value 1, and contradiction or fallacies that is always false with the logical value of 0 or false, you may say. Now from these we are going to have two main things here, that is first I'm going to move toward the identity law. What does it means? That any predicate P ended with a tautology, right? Then what will be the end result? You know that in case of AND gate, the final result is going to be true only when both these are true. ये भी true हो और ये भी true हो, right? This is known as one of the inputs is true, so we are totally dependent upon P. Either this P is going to adopt 0 or it is going to adopt 1. So P ANDed with a tautology is always going to result in P. That is, we are dependent upon the value of P. Same is the case when you are going to have P odd with a contradiction. Contradiction means 0. So this is sure if it is 0, and in case of OR gate, we just need only a true state at one side. So again we are dependent upon P. If P is false, then we are going to have the end result false. If P is true, then true odd with false is also going to result in true. So again the end result is going to be P. So ANDed with a tautology, odd with a contradiction is always going to result in the same variable. That is why it is known as identity law. Making use of again these tautologies and the contradiction, there is another law which is known as domination law. Domination law states that any predicate or variable P which is odd with the tautology, right? Now you know very well that in case of a OR gate, you just need one true state. Okay? If either of the inputs is true, output is true. So here we are having a two state here, so definitely the output will be true. In case of P ANDed with a contradiction, right? And result is very well sure, that is it is going to result in a contradiction. Why? Because AND gate has a property, if one of the input is 0, output will be 0. That is false here. So here you can say that the tautology and the contradiction are going to dominate. That is why this is known as domination law in case of OR gate and in case of the AND gate. However, in this area, this P predicate has the uh, uh, domination in the sense that this whatever is the status of P, that is being transmitted at the output end, depending upon whether you have ANDed with a tautology and ORed with a contradiction. Now coming to a very important law which is known as De Morgan's law. De Morgan's law states that a NOT operator of P and Q. This is going to result in not of P and will be replaced with or not of Q. Similarly, P or Q, it is going to result in not of P and not of Q. What about if we have not of P and Q? Then definitely not and not, they are going to nullify each other. It will result in just P and will be replaced with or and not of Q, right? So this is a very known and most commonly used law, which is known as De Morgan's law. Okay, ji. Now moving to the next very important concept, that is known as conditional operator. Symbolically, this is written with an arrow sign, and arrow is towards right. For example, we write P arrow Q. How to read it? This is also known as if then operator, right? Or you can also say P implies Q, right? P implies Q. Let's see the truth table against it, right? Say we have a predicate P, another predicate Q, and P implies Q. Before going into the truth table, the P implies Q operator is in fact not of P और Q. बैकग्राउंड में ये बेसिकली इस चीज के इक्वल है, यानी इनवर्ट नॉट ऑपरेटर ऑफ P odd with Q. Coming to the truth table, we have four different possibilities here: true, 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 false, false, true, false, false, right? The logic behind P implies Q is that if P is true, then Q is true, is going to result in true. But the vice versa is not, it is not going to go the other way around. For example, if you study hard, then you pass the test. So this is not the only way to pass the test, but one of the possibilities that in order to pass a test, you have to study hard. Or another example can be, if you have the password, you can log on to the system, right? So these are the scenarios where one thing is dependent upon the other. That is, if something is true, then the other one is for sure to be true. Now applying this scenario here, that is not of P odd with Q, on this given truth table, the status that we are going to get is that true implies true is going to result in true. True implies false is going to be false, right? False implies true is true. False implies false is also true. And you can very well verify all these values from this logical operator, putting in the values of or the status of P and the Q, accordingly taking the not of P and then or it with Q. Okay, ji. One last law against all these logical rules, that is known as inverse law, right? Now the inverse law states that any variable P which is ANDed with not of P, it is always going to result in a fallacy or a contradiction, because अगर P की वैल्यू ट्रू है तो नॉट ऑफ P क्या होगा, फॉल्स होगा. और इन बिटवीन ऑपरेटर क्या है, एंड ऑपरेटर है. एंड ऑपरेटर को कोई एक भी फॉल्स मिल गया तो आउटपुट क्या हो जाएगी, फॉल्स. So it is always going to result in logic 0, right? Let's go through the second identity, that is P odd with not of P, right? this is always going to result in a tautology. How is that so? Let me tell you. If say P is true, not of P क्या हो गया? False. In between operator is or, that is only searching for a single true value. True, false, true. इसका अगर हम रिवर्स भी देख लें, यानी अगर P false है तो not of P क्या हो गया? True. Again it is going to result in true. So every time it is going to have a logical true state, but that is in fact 1. Okay ji, now let's move to some other examples where we are going to make use of these laws and then going to solve it. Okay, and sorry, one last thing that is left here, which is known as absorption law. That is also very important and it is going to be used in a number of questions. Absorption law states that P or P and Q is equivalent to P. Similarly, P or P and Q is also equivalent to P. So this is the absorption law of AND over or over AND, that is simply going to result in the P. That is the whole statement is being absorbed into a single variable, that is P. Okay, let's do a question against it. Let me go through an example. Example is that show that P or R or Q and not of P and not of Q, not sorry, ANDed with not of R is equivalent to Q or R. Let's try to solve it, making use of all these laws and identities and rules that we have just gone through. Okay, starting with the known big identity that we are given with. Okay, write it P or R or Q, right? Let me put it here. ANDed with this whole thing, right? And just upon applying the De Morgan's law here, right? Then what I will get is not of P. This AND is replaced by OR and the whole not symbol is applied over not of Q ANDed with not of R. Please don't confuse this capital Q. Okay, let me erase it so that it may not cause any confusion here. Let me write it with small q, right? So let me put it Q here, and okay. Okay, ji. So what I have done is here on this whole area I have applied De Morgan's law. De Morgan's law. P and R and Q and it with not of P or okay. Now applying De Morgan's law here, what I get Q odd with R. Both the negations will be definitely removed here. again by applying the De Morgan's law. Now P odd with R odd with Q, right, and not of P odd with, can I write it like or R odd with Q? Definitely I can write it. How? By making use of commutative law. Commutative law, right? Okay, ji. Now this point is very important and you people have to think over it and understand it very carefully. What I can see here is that we have R odd with Q. यहाँ पर भी क्या है R odd with Q. ठीक? And this is odd with not of P. This is odd with P. Just think other way around in the sense that is A odd with B and C. किसके इक्वलेंट था ये? A odd with B, right? And A odd with C. अब इसको इससे रिलेट करें. ये समझ लें कि आपका A है जो यहाँ पे भी एग्जिस्ट कर रहा है और यहाँ पे भी एग्जिस्ट कर रहा है. ऐसा ही है ना? इन बिटवीन ऑपरेटर क्या है? और है. यहाँ पर ये वाला ऑपरेटर है, राइट? सो दिस P is acting like B and this not of P is acting like C. Hopefully that thing will be clear to you people. I have just applied the or related the same given equation with the distributive law, right? ये सेम वही डिस्ट्रीब्यूटिव लॉ है और जस्ट उसको एक्सप्लेन करने के लिए मैंने उसको 2-3 वेरिएबल्स के साथ रिलेट किया इन ऑर्डर टू मेक थिंग्स सिंपलर. So we are given with this side, that is the right hand side, which is equivalent to the left hand side. So applying the distributive law in the reverse order, I can write, just writing in front of you related A, B and C, whatever is written in front of you. A basically क्या है हमारे पास? R और Q है. ठीक? जो कि और हो रहे हैं किसके साथ? B एंड C के साथ. B इस केस में मेरा क्या है? P है. एंड ऑपरेटर ऐसे ही आ गया. C इस केस में मेरा क्या है? नॉट ऑफ P है. नॉट ऑफ P. So this equation is in fact equivalent to this equation. Do think over it and do try to understand it, right? So here I have made you make use of distributive property. Distributive property or distributive law, right? So this is very well known that P ended with not of P. Just हमने इससे पहले जो किया था negation में inverse law के अंदर, तो P को अगर हम end करें उसके inverse के साथ, this is always going to result in a contradiction, right? That is going to have a false result or zero, right? और कर रहे हैं किसके साथ? R और Q के साथ. ठीक? Now anything odd with zero, again कौन सा रूल आएगा यहाँ पर? Identity rule. This is going to be equivalent to R or Q, right? And again making use of equivalent law, this is equivalent to Q or R. So we have proved that they are logically equivalent, right? So you have to move step by step. You need to write the law that is written at each and every state, and then you are going to finally conclude that this is equivalent to the given equation. You are not going to skip even a single step here because each step is very important. And while you are going to follow each and every step, there are no chances of any mistake. Okay ji, let's do another question. Now this question states that not of P and Q ANDed with P or Q is equivalent to P, right? Okay ji, let's try to solve it again by making use of certain rules. Okay ji, now first of all, you can very well understand what I'm going to apply here. Definitely, this is demanding me De Morgan's law. So not and not is going to result in P and will be replaced by or not of Q ANDed with P or Q by De Morgan's law. Clear है यहाँ तक? Okay जी. Now again the same thing here. I'm going to apply the distributive law. ठीक? कौन सा distributive law? A odd with B and C. ठीक? किसके इक्विवेलेंट है? A odd with B and A odd with C. ठीक? अब रिलेट करते हैं कि यहाँ पे A क्या है, B क्या है और C क्या है. दोनों इक्वेशंस में आपको कॉमन चीज़ क्या नज़र आ रही है? P नज़र आ रहा है. यहाँ पर भी कॉमन चीज़ क्या है? A है. ठीक? सो ये हमारा A हो गया और B और C क्या हो गए? इसको हम B कह देते हैं, इसको हम C कह देते हैं. सो ये जस्ट एक टेक्निक है कि आपने डिस्ट्रीब्यूटिव लॉ रिवर्स ऑर्डर में अप्लाई किया और इस चीज़ के ऊपर आपकी बहुत अच्छी हैंड्स ऑन प्रैक्टिस होनी चाहिए. सो अगेन वी हैव मेड यूज ऑफ डिस्ट्रीब्यूटिव लॉ. ओके, लेट्स अप्लाई इट हियर. ठीक, अब मुझे इस साइड से इस साइड पे आना है. मैं अगेन यही इक्वेशन एज इट इज लिखूंगी इन टर्म्स ऑफ पी एंड क्यू, जो मेरे जिस तरह से मैंने ए बी और सी को रिलेट किया. सो माई ए हेयर इज पी एंड ऑपरेटर आया, सॉरी और ऑपरेटर आया. अब मैं लिखने जा रही हूँ बी एंडेड विद सी. बी मेरा क्या है? नॉट ऑफ क्यू एंड सी मेरा क्या है? क्यू. ठीक, अगेन हमारे पास इनवर्स लॉ आ गया. क्या इनवर्स लॉ आया? कि नॉट ऑफ क्यू एंडेड विद क्यू, दिस इज गोइंग टू रिजल्ट इन अ कॉन्ट्रडिक्शन. ऑड विद पी, that is contradiction means 0, and anything odd with B, which is going by applying the identity law, we are going to have P here. So what I have applied here is a distributive law, and here comes the inverse law. Sorry, I should write the inverse law here. Inverse law, and let me erase it. Here I have applied the identity law. So by applying these laws or values, you are going to have the logical equivalences. Okay, ji. Now let's make ourselves familiar with two more other terms. One we have gone through was the implication, that is P implies Q. Uh, Let me go through another concept which is known as if and only if. We write it I double F. Symbolically, we write it like this symbol or sometimes you may also see this symbol, right? Now we are going to check this both ways. It means that P of x and Q of x have identical truth tables, right? So let's draw the truth table against it. PQ, P implies Q, Q implies P, and finally P if and only if Q, right? So same states, true, 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 false, false, true, false, false. Here we have true, false, true, true. Here we have true, true, false, true. So P implies Q, true, 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 false, true, or true, false. For both cases, we are going to have false. Any one of them is false, output is false. If both are true, then definitely again the output is true. So P implies Q is going to work only when both are true. P implies Q is true and Q implies P is also true. So here in case of implication, when you were saying if P then Q, then it was a different scenario. Similarly, if you say Q implies P, that is if Q then P, then it is also the same scenario, different scenario. And while you are going for P implies Q, the only condition for being true is that both P implies Q and Q implies P should be true. If any one of them is false, the output is false. So this brings me to the end of the lecture, where we have made ourselves familiar with some logical equivalences, some logical laws. In the next lecture, I'm going to continue with some other examples so that you should have a very, very good hands-on experience on how to simplify or how to prove that one statement is equal to the other in a logical manner. If you have any queries, we are definitely going to discuss them in the interactive session. Thank you.